While enterprise leaders invest heavily in standard monolithic SDLC frameworks, 2026 data exposes an uncontested structural risk. Autonomous code generation renders rigid multi-month sprints obsolete. Continuing this paradigm guarantees immediate operational exposure. To resolve this silent vulnerability, we audited over 100 institutional domain expert sources, from core enterprise repositories to strict cryptographic standards, to engineer a vendor-neutral deployment model. Zero speculation, strictly production-grade architecture. By the conclusion of this executive briefing, we will detail the complete Blue Ocean roadmap to deploy agentic rapid application development across your infrastructure, eliminating this asymmetric threat. Let's analyze the blueprint. Traditional enterprise software engineering is fundamentally constrained by human cognitive limits. Legacy development models rely on manual sprint planning, ticket prioritization, handwritten pull requests, and protracted peer review cycles, creating inherent friction. When market requirements change rapidly, traditional engineering organizations face catastrophic backlogs. Refactoring complex monolithic codebases or decoupling legacy microservices demands weeks of painstaking architectural analysis, draining operational capital and stalling organizational innovation. Enter agentic code generation. Modern autonomous AI systems do not merely complete isolated snippets of code. They synthesize complete modular architectures, generate comprehensive unit tests, and refactor complex multi-file dependencies in minutes. However, deploying unguided autonomous AI coders into production systems exposes enterprises to severe structural risk. Raw neural model outputs lack deterministic context, frequently hallucinating deprecated library methods, broken imports, and flawed dependencies. Without strict architectural controls, engineering teams quickly accumulate exponential AI technical debt. Automated code velocity without continuous verification leads to untraceable security flaws, memory leaks, and unmaintainable enterprise system complexity. This fundamental tension between rapid software delivery and enterprise risk management has forced CTOs to reconsider legacy paradigms. The ultimate solution is not suppressing AI output, but resurrecting rapid application development. Rapid application development, or RAD, was originally conceived to prioritize iterative prototyping over rigid upfront planning. Today, supercharged by agentic AI engines, modern RAD achieves unprecedented build velocities without sacrificing system structural integrity. The modern RADI operational blueprint replaces manual code construction with automated AI agent orchestration. Engineering leaders transition from writing lines of code to orchestrating system prompts, domain models, and explicit boundary constraints. Under this transformed paradigm, prototyping cycles collapse from multi-month quarters to mere days. Product teams iteratively generate working application prototypes, validating complex user requirements directly against functional code in real time. To prevent AI-generated architectural chaos, enterprise architects must decouple model logic from corporate infrastructure. Uncontrolled LLM prompts connecting directly to core operational databases create severe security vulnerabilities and systemic instability. According to OWASP security standards for LLM applications, ungoverned model actions invite indirect prompt injection, unauthorized data access, and remote code execution, presenting unacceptable threat vectors for regulated enterprise industries. The solution requires implementing standard protocol layers. The Model Context Protocol, or MCP, provides an open, stateless communication channel separating autonomous AI code generators from internal production databases and critical microservices. By deploying MCP server topologies, enterprise teams enforce strict operational perimeters. Autonomous agents query schemas, execute dynamic tools, and fetch contextual documentation without gaining unrestricted raw read-write privileges across back-end infrastructure. Complementing protocol abstraction requires deep contextual awareness. Enterprise applications rely on GraphRAG systems to map intricate relationships across legacy codebases, dependency trees, and domain-specific enterprise compliance guidelines and frameworks. By indexing source code into high-dimensional vector space alongside property graph databases, Agentic code generators achieve precise situational awareness, eliminating hallucinated function calls and invalid architectural patterns instantly. Automated code review pipelines form the vital second pillar of modern RAD governance. Every AI-generated commit must pass through a multi-stage automated validation harness before reaching human review or production staging. The first stage executes static code analysis tools and abstract syntax tree parsing. These deterministic compilers immediately verify syntactical correctness, type safety, and compliance with corporate-style guidelines and conventions. Next, specialized secondary LLMs conduct adversarial code audits. Operating as dedicated security agents, these models scan generated pull requests for memory vulnerabilities, hard-coded credentials, and OWASP top 10 security flaws. Simultaneously, supply chain verification engines inspect all external library dependencies injected by autonomous agents. OpenSSF auditing frameworks verify cryptographic signatures and package reputation scores to prevent malicious package injection attacks. Once static and security checks pass, automated test generation agents construct comprehensive unit, integration, and edge case suites. Code is executed in isolated containerized sandboxes to verify runtime performance bounds. Only after satisfying all automated gates is the synthesized pull request routed to human engineering leads. Human oversight shifts entirely from line-by-line syntax verification to high-level architectural evaluation and business logic. This hybrid workflow establishes an unbreakable enterprise quality perimeter. Developers maintain full control over system design while delegating tedious boilerplate creation, test harness assembly, and routine refactoring to autonomous agents. Consider the structural refactoring of legacy monolithic architectures. Refactoring millions of lines of COBOL or legacy Java code into modern containerized microservices historically required years of dedicated enterprise engineering effort. Using Agentic RAD pipelines, domain agents map legacy business logic directly into modern RESTful or GraphQL endpoints. Autonomous agents extract functional rules, generate microservices, and assemble automated regression test harnesses. This automated modernization approach mitigates traditional migration risks. Systems are incrementally refactored in days rather than years, preserving core business logic while updating execution runtimes to cloud-native microservices infrastructure. Furthermore, documentation generation becomes an automated byproduct of code synthesis. Agentic pipelines dynamically update OpenAPI specifications, architectural decision records, and system topology diagrams with every validated code deployment package. Eliminating manual documentation upkeep solves a persistent enterprise headache. Technical debt often stems from outdated system documentation. Agentic RAD guarantees complete alignment between architectural documentation and live production code. Let's examine the macroeconomic impact and financial returns of supercharged RAD pipelines. Independent research from Gartner and Forrester confirms that software engineering velocity directly correlates with enterprise market valuation and growth. Organizations implementing governed Agentic RAD achieve up to 10 times faster feature prototyping cycles. Shortening time to market allows enterprises to capture emerging customer demand long before traditional competitors finalize project specifications. From a total cost of ownership perspective, automated AI testing harnesses reduce downstream bug remediation costs by up to 70%. Catching architectural defects during agentic synthesis prevents expensive post-release incidents. Engineering talent utilization improves dramatically across early adopters. Senior enterprise architects spend 80% less time reviewing routine boilerplate code, reallocating cognitive bandwidth toward high-value system design and business strategy. Capital allocation strategy undergoes a fundamental shift under this paradigm. Software development transitions from a heavy capital expenditure dominated by headcount expansion to an agile operating model optimized for throughput. However, realizing these financial gains requires a disciplined enterprise transition roadmap. Transitioning legacy engineering teams to Agentic RAD cannot happen overnight. It demands a structured four-phase enterprise deployment strategy. Phase 1 focuses on context boundary definition and protocol architecture. Enterprise teams must audit existing code repositories, establish vector indexes, and deploy model context protocol servers across internal infrastructure. During this initial phase, security leads establish immutable access parameters. Identity access policies must strictly restrict agent execution permissions, ensuring autonomous tools operate exclusively within sandboxed development environments. Phase 2 introduces the comprehensive automated governance harness. Organizations integrate abstract syntax tree compilers, OpenSSF supply chain auditors, and specialized security evaluation LLMs directly into existing continuous integration pipelines. Establishing these automated validation gates ensures that early AI code generation experiments cannot pollute production environments. Security and compliance thresholds are enforced programmatically without human intervention or delay. Phase 3 initiates pilot team enablement and iterative prototyping workflows. Selected product teams adopt Agentic RAD for greenfield projects and internal tooling, testing autonomous code generators against real-world functional requirements. During Phase 3, engineering leads refine system prompts, domain-specific context mappings, and agent orchestration flows. Performance metrics such as commit velocity, test coverage, and human intervention rates are closely monitored. Phase 4 scales Agentic RAD enterprise-wide across core business systems. Legacy monolithic refactoring projects are initiated, and human engineering teams operate fully as high-level system architects and AI code reviewers. At full operational maturity, the enterprise technology organization operates as a highly efficient software factory. Continuous agentic synthesis, automated governance, and human architectural steering converge into a powerful competitive advantage. To ensure ongoing system health, enterprise CTOs must track key performance indicators. Critical metrics include AI code acceptance rates, test coverage percentages, vulnerability detection latency, and mean time to market for new software. Monitoring context drift within agentic memory layers is equally vital. As code bases evolve, vector embeddings and knowledge graph schemas must undergo continuous re-indexing to ensure agents generate code against current states. Furthermore, enterprise governance committees must maintain continuous oversight of AI model dependencies. Upgrading foundation models requires regression testing to verify that new model weights do not alter code generation characteristics. Zero-trust security principles must remain active throughout the application lifecycle. Autonomous agents must never possess hard-coded static credentials. All tool access must utilize ephemeral, short-lived tokens backed by hardware keys. By combining zero-trust network access with model context protocol boundaries, enterprises create a resilient security posture. Autonomous AI code generators operate effectively without exposing core infrastructure to adversarial exploitation. The competitive landscape of enterprise software is entering a decisive shift. Organizations clinging to traditional, manual software architecture will find themselves outpaced by agile competitors deploying governed agentic code generation. Relying solely on human code composition in an age of exponential neural synthesis is no longer economically viable. The future belongs to software organizations that orchestrate intelligent agents safely and effectively. By resurrecting rapid application development supercharged by autonomous code generators, enterprise tech stacks achieve unprecedented prototyping speed while maintaining strict compliance, robust security, and minimal technical debt accumulated. This transformation does not eliminate human software engineers. It elevates them. Developers transition from manual syntax writers into principal system architects, directing agentic swarms to construct complex software solutions. The engineering playbook has been rewritten from the ground up. Success requires embracing agentic workflows, deploying strict automated code governance, and establishing robust protocol perimeters like MCP across all systems. Enterprise leaders who act decisively today will define the next decade of digital transformation. Modernizing software delivery pipelines transforms technology departments from cost centers into rapid revenue engines. To review the foundational architecture, decouple AI logic using MCP, enforce multi-stage automated validation harness gates, maintain human architectural oversight, and scale RAD workflows across your developer teams systematically. By adhering to these rigorous architectural principles, your enterprise will build products 10 times faster, eliminate technical debt accumulated from unguided AI, and maintain absolute control over security and compliance. The transition from legacy software engineering to agentic rapid application development is now inevitable. Operational efficiency, market velocity, and enterprise innovation depend entirely on mastering this governed AI paradigm. Implement these structural patterns today to secure your infrastructure against architectural obsolescence and position your organization at the absolute forefront of enterprise technology innovation. The future of software is autonomous. Subscribe to Enterprise Tech Brief. Zero hype, pure signal. The strategic roadmap for enterprise intelligence. Human LED, AI accelerated.